Dance.
Hello everyone, welcome. Glad you could join me. You are obviously interested in speeding up your executions of user-defined functions. Either that or you're in the wrong presentation. So let's get started with that. First of all, who am I? I'm Erik, and on the bottom right you can see a couple of ways to get in touch with me if you wish. I'm an Oracle ace. I didn't always work with Oracle technology. I used to work in laboratories, but I couldn't do that anymore because of some accident I had. It's not important. I've been working with Oracle technology since 1995, and after some time I decided to not work for a boss anymore. Most of my work is inside a database, so SQL, PL/SQL takes a lot of my time. I play with Apex, but I'm definitely not an Apex developer. And data migrations are a very important part of what I do every day. If you're interested in the ACE program, if you would like to become a part of the ACE program, then this slide is for you. There's some links on there where you can find all the information that you want. So have a look. What are we going to do today? Well, first I'm going to tell you a little bit about the problem, just a little bit, because we have a lot of other things to talk about. Then what we could do before 12c, to solve this problem, and then what is new as of 12c. And in the end, I will show you some performance tests and the results of those to see how much faster things can be. Okay, so what is the problem? Well, I think it should be clear to everyone by now that there is a SQL and a PL/SQL engine, two different engines. And as soon as we start mixing SQL and PL/SQL, we have context switches between those engines. And if you do that a lot, then it takes a lot of time and it will slow down everything. When we call a SQL from PL/SQL for quite some time now, we've had the bulk operations. So we had a fix, or kind of a fix for that. It speeded things up a lot. But for the other way around, we didn't have that until Oracle 12. In Oracle 12, some things happened. And first of all, I want to stress that what we're talking about is not going to eliminate the context switches like they do with the bulk processing. The bulk processing makes sure that you have a lot less context switches. What we're talking about now is not going to reduce the number of context switches. It's just going to make the context switches faster, so they hurt less. Before 12c, and obviously now we still can do that, but then we could, well, obviously do not do PL/SQL. Well, it's a bit silly, but yeah, it's the first thing that you have to look at if you want to speed things up. Maybe we can just not do that PL/SQL, but sometimes you have to. If you have to, then you can make it as fast as you can. And there comes a point where you will say, well, this is as fast as it can be. It cannot be any faster, and it's still not fast enough. Then if the function was deterministic, you could declare it deterministic, making sure that the database doesn't unnecessarily execute it. If it has been executed with the same parameter set before, it will just reuse the result it had back then. And we could use the function result cache, which gives similar results. And we could make use of scalar subquery caching, again, similar results. Well, of this list, number 1 and 2, that's always a good idea, no matter what. 3, 4, and 5, however, they only speed things up if you have a lot of executions of your functions with the same parameter set. If you have a lot of unique parameter sets, then you don't get a lot of performance gain because these executions will not be skipped. So in 12c, they thought, you know, we want SQL, we want PL/SQL, let's just combine them. And let's have functions declared in the with clause. How do we do that? Well, here's a function. It's a silly function. It takes an integer as a parameter. It just takes the integer apart and sums up all the digits and then returns that result. Not very useful for your everyday life, I think, but it's a function. It works. It's for demonstration purposes fine. Well, I have this function. I put a with clause in front of it. I put a query after it that makes use of this function, and we're done. This is how easy it is. I want to make a remark straight away. You see the slash over here. If you run this in SQL Plus or SQL CL, then you must end your query with a slash and not with a semicolon. If you do it with a semicolon, it won't work. The SQL Plus and SQL CL will just think you are still typing in your statements. The end of a statement is a slash, so you need to do a slash. Another remark, if on my slides you see a block like this, it refers to a script that I will deliver with the slides later on. So if you download the slides, you will have the scripts as well. So you don't have to type this all, you can just use those scripts and it's there. Okay, if we run that query that we had on the previous slide, then we see that it actually works. It sums up the object IDs and, well, I'm not going to calculate it for you right here. You're just going to have to trust that this is correct. You can have a look at it later on by yourself. A warning. This is something that is true for every PL SQL that you run from a query, but I see a lot of people making the mistake of thinking that if this PL SQL, this function is inside that query, well, it's part of the query, so it's obviously also part of its read consistency. It is not. Absolutely, it is not. It's just a function like any other function, so it behaves like any other function. Don't make that mistake, please. To prove that, I have a query here. In the with clause, I get a timestamp from a query. This could have been done a lot easier, but I wanted the structure to be similar to having a function in the with clause. So I select a timestamp in the with clause, and for 10 rows, I want a result. When I do this, then we see that each and every row gets the exact same timestamp. Why? Because there's read consistency. You get the truth that was the truth at the start of the query. If we replace that selected with clause by a function that returns a timestamp, then if we run this, we see that every row has a different timestamp. Why? Because the function returns the truth at the moment the function was called. So for each row, you get a different timestamp. Don't make this mistake, please. Okay, a function in the with clause. As we have seen just now, you can just put it in the with clause, but that was in the with clause of a top level query. But you can do it anywhere you can have a with clause, also in a subquery, also in a insert as select and in a merge statement. You can do it anywhere you can have a with clause. However, if it's not in the top level query, then suddenly the compiler gets confused and it doesn't understand what you're doing. So we have to warn the compiler by using this hint with PL SQL. I don't know why this is. It's been explained to me that it has something to do with security, but they haven't been able to explain to me why this is more secure, or more importantly, why the security issue isn't there if the function is in the with clause of the top level query, because then suddenly we don't need this hint. Anyway, as some president tries to say, it is what it is. You don't have to use it if it's in the top level query. You do if it is not. An example of this, a query with an insert as select with a function in the with clause of the select. No hint here. If we would try to run this, then we would run into this ORA error. If we add the hint, then it would be successful. Note that there is a bug in SQL. I hope it will be fixed soon, but if you're using SQL and you execute a function like this, one of the functions that needs the hint with PL/SQL, then it will not work because the parser will stop at the first time it encounters a semicolon. As soon as it sees a semicolon, it says, you probably just at the end of this SQL, and then it realizes that this is a wrong SQL, it can't execute this. So there's a bug. I hope it will be fixed, but at this moment, you can't do this in SQL. Syntax errors. If you have an error in your PL/SQL and you have that PL/SQL in your with clause, the only message that you get will be that there is a missing keyword. Always, no matter what the error is in your PL/SQL, the error you get will be missing keyword. Well, that's useless. I have an example on the screen. It's a very simple function, and as you can see, I forgot the semicolon after the return statement. This won't compile, but if I run this, it says missing keyword. Now it's easy to see where the error is, but if your function is more complex, more lines, whatever, this is not going to help you to find the error. So what I suggest, if you want to do this, is to develop your function first within an anonymous block and run that. The anonymous block doesn't have to execute the function, just execute nil until it compiles. Because if you do it like this, you will get sensible error messages and you will be pointed to where the problem is. It's a lot easier to develop your function this way. And once it compiles, you can take it from here, put it in your function and see if it actually does what you want it to do. Can we have only functions in the with clause? No, of course not. We can also do procedures. Obviously, procedures, we can't execute them from SQL. We can't execute a procedure. That's just one of the limitations. But we can execute a procedure from a function in the with clause and then execute the function from within your query. An example here, here's a procedure and there's a function that calls that procedure. We put it in the with clause and we call the function from the query. Sorry. If we run this, then we see that it actually works. So we can have procedures and we can execute them from other procedures and functions in the with clause. I personally don't expect to see a lot of queries with procedures declared in them, but at least now you know that if you need it, you can do this. How about speeding up things even more? I mean, this is all supposed to speed things up, but as I told you, before 12c, we already had things like result caches, stuff like that. What if we combine that? We could use the function result cache, deterministic, subquery caching. Well, that would be nice if we could do that. Well, function result cache, unfortunately, if you try to do that, you run into an error message. Your statement will not compile. It is not allowed to do that. Deterministic, it's ignored and it's unreliable. Scalar subquery caching, it's simply ignored. So it looks like none of these can be combined with a function in the with clause. Let's have a look at what will happen. This is a function in the result cache, so a function in the with clause with result cache. If we run this, as I told you, you will run into an error in implementation restriction. So this is out of the question. Deterministic. Well, if you add the deterministic clause to your function, nothing will go wrong with your query. It compiles, it will run. But in 12.1, the deterministic clause is just simply ignored. It won't do anything. So whether it's there or not doesn't help you at all. In the next versions, until 18, sometimes it worked and sometimes it's ignored. Well, you think, at least I can just put it in there. If it works, great. If it doesn't, well, too bad. But unfortunately, sometimes it gives wrong results due to a bug, and that is worrying. So with just this in mind, I would already say just don't use deterministic, at least not in a function in the with clause. And then in 19, well, deterministic is ignored again. Well, that's one way to solve the bug, I guess, but unfortunately, the bug is still there. So let me stress again, just don't use deterministic with a function in the with clause. This is an example of deterministic that does work. If we run this query, then the query itself, it produces 8 rows. It produces the numbers 1, 2, 3, 4 twice. So we expect the function to be executed 4 times. 8 rows, 4 executions of the function because there are duplicate numbers. If we run this, it's exactly what we get. 8 rows, correct answers, and 4 executions of the function. Now we change this statement, this query a little bit. The only thing we change, we'll go back and forth. The only thing that you see is changing is the return was an integer and is now a varchar 2. If we run this, we see 8 executions for the function. So deterministic is suddenly completely ignored. And here is an example of wrong deterministic results. It's again the same function. The only thing that is changed is in the query. Now we produce 4 rows, and with a mod of the level, I produce the numbers 0, 1, 0, 1. I really don't see why this is so much different than the other query. But if we do this, then we see that the function is executed twice, what we would have expected. But after the second execution, the database just gives up and just keeps returning the result of the second execution. And that is pretty wrong. The third row in this result should have been a 1 as a result, and not a 0. This is caused by this bug. If you would like to look it up in MOS, then that's the number. And there is a workaround. You can set this parameter, the PL/SQL cache enable, to false. But that will mean that you will turn basically deterministic off for your session completely for every statement until you turn this back on again. And because this basically just turns off deterministic, and you're doing this just to fix the fact that you have a deterministic clause in a function in the with clause that shouldn't be there in the first place, in my humble opinion, I think you should just not do this and just not use deterministic in your with clause. Those wrong results that we just saw, it also depends on the client that you're using, what the wrong results are. Because if I run this in live SQL or from Apex, because live SQL is run from Apex, then you don't run into this bug. The results are correct. I don't know why. Maybe Apex sets that that variable that we saw, that's the parameter that we saw. I don't know why, but fact is that if you run it from Apex, you have the correct results. If you run it from SQL+, then you get the results that I showed you before. If I run it from SQL+CL, then even after 1 execution, the database gives up and just keeps returning the result of the first execution. So the client you're using is also important in what results that you actually get. Scalar subquery caching. It does work in 12.1, but not in later versions. So if you're on 12.1, you could do this. Execute the function by doing a select function from Joule, then the database can take advantage of subquery caching. And if we run this in 12.1, then indeed we see 8 rows and 4 executions. But in all later versions, we see 8 rows and 8 executions. So it's not really an option. Another bug I want to warn you for, it's a very specific case, but I ran into it once and thought I would mention it to you. If you have a merge statement and you have PL/SQL in the with clause of the using, and you use bind variables, then you will run into this, and you will probably get a nice call from your DBA asking you politely what you are doing. So watch out for this. PL/SQL is not supported, PL/SQL in the with clause is not supported within PL/SQL yet, I think. Yeah, maybe in the future they will support it. If you try to declare a cursor that has PL/SQL in the with clause, then again you get missing keyword. You can do it with dynamic SQL, of course, because then the statement is just handed over to the SQL engine and that one knows how to handle this. But if you're already in PL/SQL, then why have a function declared in the with clause of your cursor? Why not just declare a function within your PL/SQL with pragma UDF? Because yes, we have another option as well, pragma UDF. You can add this pragma to any standalone or packaged function. And it instructs the compiler that you will use this within SQL primarily. And the documentation says it might improve performance. And that might is very well chosen, because we will see in the performance test later on that it doesn't always improve performance. Okay, how? Well, this is a basic function. And how do we make this a pragma UDF function? It's really simple. You just add pragma UDF and done. What are the advantages? Well, basically all the disadvantages that we saw with the with clause do not appear with the pragma UDF. You do not have to use a with PL/SQL hint. You get sensible error messages. You know where the problem is. You can use function result cache. You can use deterministic, although the behavior is exactly like in the with clause, but you don't run into that bug that I told you about. So at least you don't have to worry about wrong results. And you can use scalar subquery caching, and you can use it in a merge statement with bind variables. And probably the most important one, you can reuse that function in any query that you want to use it, instead of the query in the with clause, which obviously can only be used within that single query. But there are also disadvantages, of course, because as a wise man once said, if there was a best way of doing things, we never would have invented any other ways. The disadvantages are mainly, well, first of all, you need to create a database object. You need to create that function inside the database. And if you just have a query that you want to run on several databases, or you want to run it on production or whatever, you're not always allowed to just create that function just because you need it in your query. So if you're in that situation, then it might be better to just put it in the with clause of that query. And the performance gain of this is less predictable than when you do it in the with clause. And we will see that later. So performance, we have been mentioning it a lot of times now. So what is the performance gain of this? I did quite a lot of testing. The test scripts will be delivered with this presentation too, so you can run it yourself if you want. There's first this script, the setup script, that creates 3 tables and a package. The package does all the important stuff. The input table, that's just a bunch of rows, and the function gets executed for each row in that table. The tests script table defines the tests that will be run, And the results table, as the name says, will contain the results of individual executions. Then you run the tests. It prompts for a number of rows to put into the input table. I used 5 million rows, but you can use whatever you want. Then it runs all the tests and it writes the results to the tables. Then you can query the tests for the test table for your averages. You can query the results table for individual executions. And then you can clean up everything by running the cleanup script. Pretty simple. A word of warning before we go on. If you start running this, I noticed that the functions in the with clause, well, they use up a bit of PGA. Well, that's not that bad. It's not a lot, but it appears that if you do this, then that PGA will not be released until the outermost PL SQL block that you executed is finished. In this test, I will run, as you can see in here, eventually 3.6 billion function calls within one PL SQL block. So in the end, I ran out of PGA memory and I had to increase it quite a lot to be able to run this test. I think this is a bug. I'm not sure yet, but we are investigating it, and it's something to be aware of. It's like I said, it's not a lot that it's not a lot that each execution takes, but if you're doing a hell of a lot of queries like this within one PL SQL block, it might cause a problem. The performance tests. What did I do? Well, there's a table, it contains rows, and for each row the function will be executed. I have a view that does nothing than select from the table. And there is a procedure that does a bulk collect from the view. And the execution of that procedure is what is timed. Then we have tests of different types. We have plain SQL. In that case, the view will just select from the table and will not perform a function call. There is single function test type, and in that case, the view will execute a function for each and every row in the table. And that function can be a regular function, as we always used to declare them, or a UDF function, or a function in the with clause. Then there's the test type nested function. In that case, the primary function calls a secondary function. And that secondary function can then be of types regular, UDF, or of DBMS, which means an Oracle function that is in one of the DBMS packages. In my case, I chose get hash value from the DBMS utility package. Obviously, the secondary function is not a with function because, well, we want to call out of the with function to that. Then we have a small test of pipeline table functions that is separate from the rest of this, just to see if that gives any performance gains. And then we have several function complexities. The first one I do is a no-op function. That means that the function really doesn't do anything. It just gets a parameter and it returns a constant value. It doesn't do anything else. Then there's the simple function. That one just returns the result of a case expression. And I call it simple because what the function does could be just copied out of the function and just planted into your query, and it would just work. And then there's complex, and it's not complex because it's hard to understand or whatever. It's just because it's the result of a loop, and you can't just take that out of the function and put it in the query. It really has to be in this PL SQL. This results in a lot of tests. And how do I execute it? Well, I run each test 11 times and the first one is discarded. Then we calculate the average of the other executions. The tests are executed for different combinations of parameter and return data types, namely these combinations. All tests were done with PL/SQL optimized level 2. I've done other tests with other optimized levels as well, but I've seen no significant changes in that. So what I'm presenting here is just optimized level 2. In total, there are 211 distinct tests. And in the results, you will see that the baseline is highlighted, and it's usually the regular function that is the baseline. So we compare the other results to this baseline. The runtimes are not seconds, not minutes, not anything. It's percentage. It's a percentage of the baseline. We just want to see how the percentage of time it takes compared to the baseline. The conclusions. First, another warning. These are the voyages of the Starship Enterprise, not from the Millennium Falcon. What I'm trying to say is these are my results, not yours. If you want to know what the effect is in your everyday situation, test it there. You can use these results to get a feeling for what you can expect, but don't expect it to be exactly the same as in your situation. So let's run a test with a single function. Then these are the results. We have a single function type, and the complexity is no op. As you can see here, the regular function is the baseline, so by definition it's 100%. And then if we look at the other results, then we see that, well, no surprise, plain SQL is always the fastest. Well, that's, like I said, no surprise. It would have been a real surprise if that wasn't the case. The performance gain, it depends on the data types of parameter and return value. As you can see here, for example, the UDF function, there's no performance gain if the parameter is number and the return type is date. But there is a significant performance gain if the parameter is number and the return type is varchar. So it depends on the parameter and return value. And that's a bit surprising, maybe, but yeah, it is what it is. The execution of a UDF function is faster than a regular function. Well, that's what you expect, but it only is true for certain data type combinations. And when a UDF function is faster, it's also a bit faster than the function in the with clause. Not a lot, but a bit. And execution in the with clause is always faster. It doesn't depend on the data types. And that's quite nice, I think. It's like I said before we went into the test results. It's a lot easier to predict your performance gain when you use the with clause than when you use a UDF function. This was a no-op function. Maybe it's different for a simple function. Well, no, it really isn't. If you look at these numbers, then they are basically just the same. There's a slight difference in the numbers, but you see again that, for example, number to date doesn't have any performance gain for UDF, and it does with number to varchar, and still with clause is always faster. Numbers are a little different, but overall you see the same results. Now if we go to a complex function, again, basically the same results. Numbers are a little different, but basically same results. So let's go to a nested function. So now we have a function that will call another function. These results are only from complex functions, because as we have seen that no-op and simple or complex, there's no real difference there. So I will just show you the complex ones here. And then these are the results. And again, it's basically the same. If we have a regular function calling a regular function, that's what we used to do, that's the baseline. But if we have a UDF function calling a regular function, then we see that it's basically the same as calling just a UDF function. It's a little slower, but it's probably because it has to do more work because it has to call two functions. And a with clause calling a regular function is also, you see the same performance gains, and that is pretty awesome. We have a careful conclusion maybe that it looks like the second function is somehow inlined into the first function and thereby gaining the same advantages that you get from just that first function. If it's a UDF function or a with function, you get a performance gain no matter what the second function type is. And that opens possibilities, as we will see a little later. So if the second function is a UDF function, if we do that, then we see that calling it from a first function regular, then there is no performance gain. If your first function is regular, then the second function UDF, no performance gain. If both are UDF, we see similar results as before. And with clause calling a UDF function, again, similar results as before. So when the primary function, oh, sorry, I've just said that. So in a chain of functions, it seems that the first function in that chain defines what your performance gain will be. That defines the type of function that defines how the functions will be treated. At least that's what it seems. If the second function is one of Oracle's functions, one of the DBMS functions, what then? Well, again, we see that we do have a performance gain if the first function is a UDF or a with. The same type of, the same sort of performance gain that we saw before. So even when it's a function that we do not control whatsoever, we could get a performance gain by just calling that function from a function that is either a UDF function or a function in the with clause. And that is pretty neat. Pipeline table functions. We do that, this test is with complexity complex, and for all these tests, it was just one test. If we look at the results, then that's a bit disappointing. There is absolutely no performance gain whatsoever. And I've been told that that is because the pipeline table functions, well, as of the first day that they were developed, they were meant to be called from SQL. So they have been optimized for that as of day one. So you don't get a performance gain if you make it a UDF pipeline table function. Sorry. My general conclusions. Well, function in the with clause. You can't do everything with it. There are some limitations, but if you use it, you will get a performance benefit, period. If you use Pragma UDF, well then you can do everything you can do with any normal function, but it doesn't always give you better performance. Functions calling other functions, well, the type of function that is called by the query seems to be the one that determines how all the functions are executed. So we could wrap regular functions. If you have a function that is already developed, you don't have to change it into a UDF function. And sometimes you even can't do that, like with the DBMS functions. But you can just add a with clause to your function, to your query, sorry, and have a function in there that just wraps that function that is already there. That function in your with clause could be very simple. It just calls the other function and returns its result. And then you can get the performance gain from the function in the with clause. Unfortunately, you can only do this within SQL and not within PL SQL. If you want to do it there, then you will have to do dynamic SQL. And those were my conclusions. So I'm a bit ahead of time, 5 minutes, but are there any questions? Let's have a look. Yeah. Q&A. I see one thing in the Q&A. Can a select statement with inline PL SQL be used in Apex as, for example, region source, or in database as a view body? I tried once but got invalid select error. Maybe hint will help. It's a good question. I have not tried it with Apex as a region source. I think it should be possible because Apex does nothing really with that. It just executes a query. As long as SQL recognizes your query, I think it should be okay. So I think you should just have to try that. I haven't tried it. I expect it to work. Or in database as a view body, well, yeah, that should work. I have created some views with PL SQL in the select, in the with clause, sorry. So it should work. If it doesn't, then probably you had like an error. Maybe you did indeed needed that with PL SQL hint. Is possible. It should work. If it doesn't, then either you ran into a weird case where it doesn't work, or maybe you didn't do it correctly yet. So have to try again. Next question. When I put the function in the with clause, I need it in every one of the queries. Any workaround for that? Yes, that's true. That's what I said. One major advantage of doing it with a UDF function is the fact that you can reuse it anywhere you want. The workaround for that would be to have your function declared as a normal function, but then have your the with clause in your query just wrap that function. Then you can basically reuse the actual implementation of your function, that is a regular function. And in the with clause, all you will have is just a wrapper for that function. Then you will get the advantage of performance gain of a function in the with clause, and you still have the implementation of your function in one place. I hope that makes sense for you. Wrap it. Okay. And the reaction is such that I think that he got it. Okay, anybody else? Any other questions? I don't see any other questions coming in. So then I think this is it, and then I thank you all for listening to me, and then I hope to see you tomorrow with my other presentation.